There, can you guys hear me?
Yeah. Yeah, we hear you.
Good. Good, there you go. All right, starting to see some faces. Let me pull up. All right, oh good, I already got 21 participants. I never know how much to expect. All right, well, welcome. I don't know if we need to give a few minutes for other people to log in. So, welcome back. I hope you're all doing well. I have been getting a lot of updates from the university administration. So far as I know, I haven't had any of my students come down with this new virus, but I have had some students that have already been caught in one way or another. They have elderly relatives that they have to care for, or they have new child care responsibilities. One person's spouse is a nurse, and she's got to go off, and so he's stuck with the daycare responsibilities and can't Zoom in with the rest of us. So I'll try to be accommodating for you. If you have any problems like that and you need to let me know, or just send me an email and I'll try to do what I can for you. I was hired as a mathematician, so the thing that I can help you with most is the math, but I also serve as an advisor, and I've been given some hints about how to give resources to students that need whatever kind of assistance you might need. For starters, I guess you guys have probably been told through the dean's office, have you, that they've changed all the deadlines for things like changing a class to pass-fail or Q-dropping a course. I hate to say this, but it's almost like this semester grades don't matter, in the sense that as far as I can tell, if you feel that you're at all close to failing this or any other class, up until the very last class day, you can just choose to Q drop it, and it won't go against your limit of Q drops. And then if you stay in, then you get a grade for the semester, and if it's any grade that you don't like, then you can change it to just a P for pass, and that will satisfy any university requirements. So it seems like you can just relax about grades and just focus on learning some math. If I've misunderstood, maybe somebody better tell me fast, but if what I've understood is correct, this seems like the perfect opportunity for us to just focus on, we'll just learn as much number theory as we can, and we don't have to worry about anything else. I will continue. I have had to submit a revised syllabus. If you go to the math department web pages, you'll see I've updated our syllabus with a lot of changes to reflect the current reality. But as much as possible, I'd like to hold to a pattern of meeting with you guys 3 times a week. And I'll assign you homework once a week or so. And the grader has already said that he'll be able to get things back to you if we submit them through Canvas. We're supposed to have another midterm and a final, but I'm not entirely sure how that's going to work. If you guys all have the ability to use something like Zoom or Skype or FaceTime or something, then I can give you a take-home exam and maybe schedule a time to meet with each of you for, I don't know, 15 minutes or something, and just have you discuss some of your answers to the questions. And then that would be a little more thorough and immediate feedback for you. So all I can say is we're going to play it by ear, and I'll try to do my best for you and give you whatever I can. As far as Zoom goes, I'm going to try to record these Zoom sessions. There's some kind of weird conversion that the recordings have to go through, and then I have to upload them. Because of the length of the recorded videos, we're going to run past our limits of what you can store just on Zoom or just on Canvas. So I've already set up a YouTube channel just for this semester for my classes, and I guess I'll put these videos up there. You guys have been pretty good so far in the semester. When we get together, you've been just interjecting whenever something was unclear, or you had to make a correction or something, or you just had a question. And to the extent possible, I'd like to continue to do that this semester, but I know not everyone can join us on a regular basis, so you can use the recordings. My default would be that the recordings would just be a backup. If you guys tell me otherwise, I could just record lectures, and then we would never have a group meeting like this, and you could just look at the lectures on your own and read the book on your own, and then I would be there for office hours. So let's try it anyway for this week. We'll just continue to meet and give me some feedback and let me know how it goes. I sent you all an invitation to get here, and it kind of looks like basically everybody was able to get here today, which is great. Some of you, let's see, I don't think anybody joined by phone. I know that's a possibility. Some of you are joining with a webcam and some without. That's fine, whichever way you want to do it. I think I set it up so that you all come on muted by default. If you want to unmute, then there's a little icon, and at least on my screen, it's in the lower left, or you can just press a space bar and hold it when you want to say something. So by all means, just jump in if you feel like you need to. If you open the list of participants, then underneath that is a bunch of icons, one of which is the raise hand icon. And if I see that show up, then I will for sure stop what I'm talking about and give you a chance to say something. There's also this little chat feature. If you open the chat bar, then it gives you a chance to type in stuff. I'll tell you, in my experience, it's pretty hard for me to monitor both the faces, the video, and also people's chats. So maybe you just want to use that among yourselves, and then if there's something that you need to say to me, it's probably more efficient if you just stop me or click the raise hand button. Is that good? You guys all right with this? How are you all doing? Where are you? Is anybody out of the country? Anybody out of state? I had.
Back home.
You're back home in Turkey.
It's 10 p.m. right now.
I'm sorry.
It's okay.
Yeah, I had somebody call in earlier from Oman, and she said, I don't know. She said she didn't know how long she's going to continue the synchronous education. But I'll do my best for you, Yagil, and try to make sure that you have something that's either worth showing up for, or else you can download the videos later. I'll have to send you guys.
I'm still living with the U.S. time zone, so it's okay.
Oh,
I go to bed late and I wake up late.
Okay. Are all your other classes using Zoom as well?
Yes, but I haven't experienced them yet. This is my first Zoom class.
Oh, I see. Well, congratulations. You made it work, and welcome.
Yeah, so far it's working fine.
Hey, does anybody else have any hardware or software issues that they want to tell us about? Maybe somebody else in the group can help you. This is all new to me, I got to tell you. Until 2 weeks ago, I had never heard of Zoom, and now I'm using it for hours every day. So I'm not exactly an expert, but I have learned a few little tricks. So if I can help you, I will try to jump in. Listen, my calculus classes have got a Piazza group set up. I'm not sure whether one has been set up for this class by default. If it has not been set up and you want it set up, I can try to make that work. For those of you who don't know, Piazza is a forum where you can just type in your questions or comments, and other people in the group can answer them. It can be very useful as people try to work on projects together, try to answer questions together. I 100% support it if you want to do it. If you're looking for me to jump in and answer questions, I could try. I'm not sure that I can guarantee that I would remember to do it. But if you guys want to have it happen, just let me know. The rest of the math department is setting these things up, and so there is a way to make it happen. There might be one set up for all sections of Math 328, and you guys are certainly welcome to participate in that. I will tell you that not all there's like 4 sections of the course running this semester, each with a different instructor, and we're all doing things kind of differently. So maybe that's good, and you get a chance to hear different perspectives, or maybe that would just confuse you. I don't know. I don't know what else to tell you about technology. Yes, Jacob, go ahead.
I can, like, let's say we want to like express an answer or like a question, but we don't know how to like, I guess speak it that well. Can you enable the whiteboard option for screen sharing? Because I know there's a whiteboard option for screen sharing, and it like pops up a little whiteboard that we can like draw on or something.
Do you know how I do that? Does anybody know how I make that happen? I know what I can do is enable you to share screens. One participant can at a time. I don't know. I think I set it up so that the default is you do not share your screens, just because I didn't want somebody to be doing it by accident.
Yeah.
But I don't know if somebody wants to try sharing their screen. It's certainly a feature of Zoom. And then if you have some kind of writing facility on your own, in your own screen, then you could write things for the rest of us to see. I mean, Jacob, do you have something that lets you draw with your mouse just on your own screen?
Yeah. I mean, I have my mouse. I mean, I can write with my mouse if the screen share. Let me see.
Yeah. So for those of you who don't know, the screen share option, for me, it's a bright green thing, a bright green icon at the bottom of the video display. Jacob, can you share your screen?
No, you have it disabled, so I can't really do it.
Shoot. How about if I say, can you try again? Because now I said multiple participants there simultaneously.
There you go. Can you see the whiteboard?
Yes. Oh, okay. So there. Yay. How do you feel writing it out this way? Is this comfortable?
Yeah. I mean, I'm pretty sure I'll just get used to it. Okay. I mean, I've done this before. So.
By the way, are you sure you want to do this where the multiplier here is not co-prime to the modulus? You chose...
No, I do not want to do this, but I just, it was just like writing something.
Okay, quick quiz. So you realize that the problem that he just wrote has no solutions. For any integer x, 4x will be congruent to either 0 or 4 mod 8. So if you add 2, it's only going to be congruent to 2 or 6 mod 8, but never congruent to 0. So there. Thank you. You just gave us our first little number theory lesson.
I think you can also draw on it. Like other people can draw on it too, as we go along.
You know, I did see that somebody is writing. Yes. Well, now everyone is writing.
Someone requested. You can request remote control of your screen. Oh, so since I started screen sharing, I can approve or disapprove of people.
That's interesting. Oh, who did the text? Somebody typed text too.
Oh, I did the text.
How? How do you do that?
Yeah, there's if you pull down the annotation bar, there's a whole bunch of tools up here. Like the people who don't own the whiteboard could put little arrows up to like direct stuff. There's a text option.
I can relinquish my control and possibly give it to you. So like if I stop screen sharing, I think if you start screen sharing with the whiteboard, it should give you the option. Like you should be in control.
Yeah, only one person can screen share at a time, and they can choose when to relinquish it. But anybody else, even if it's not the whiteboard, like if they're just sharing some sort of like Google Doc or something, they can annotate on it.
Interesting.
So I'm gonna stop the screen share, and you should try to put the whiteboard up. See
Where
if
did
you
you
can-
find the whiteboard? Is that a Zoom
at the
feature or something that's on?
No, it's a Zoom feature. You just go down to share screen, and it should be an option. It should give you multiple options to show different windows, and one of
Oh,
them
I
should
see.
be
Ah, right.
whiteboard.
That's interesting. I didn't even know that that was there. That's good to know. All right, there. So that's me. And do I have to do something to make it available to the rest of you?
Nope, we all see it.
Yeah.
But I mean,
I-
you all now have the ability to write on it. Yes, apparently you do.
Yes.
Okay. That's interesting. Let me turn it off for a minute because I was going to show you what I did have. Well, no, wait. How do I stop share?
There you go.
Okay. So I usually use my desktop machine, which had no webcam or anything, and so the department bought me a little webcam, and I mounted it to this swing arm lamp that has a bunch of joints and stuff, so I can move this thing all around. And in particular, I can rig it up now so that I can do essentially a document camera, which is how I thought I would do whatever I would ordinarily do on a blackboard. Because for me, this feels very natural to just write. So 4x plus 2 congruent to 0 mod 8. That's a lot easier for me to write, and I don't know if that's easier for you guys to read or not. At least it's faster. So this is probably what I would do when I don't want to look at you guys, but it is a little weird because in our class, ours is a good group. I mean, it's 20-some students that meet at once, and we can kind of have a conversation, and I'd like to keep that going. And you guys have already been starting off on a good note today. But if I really do need to, essentially write on a blackboard, this is a better way for me to do it. Now, how would I do it so that you guys can write on this? I don't know. No.
I suggest to make it more efficient for you, there are like devices that you can connect to your computer so that it's easier for you to write. It's like they have a pad and a pen, like a pencil.
Yeah.
And I suggest proposing that to the university to see if you can get it for you. If you want to go to the electronic stuff, electronic whiteboard.
Yeah, part of me has been resisting. I'm kind of hoping that we'll just get to the end of this semester, and then in future semesters, I'll just be able to see students face to face again. I mean, you can't teach an old dog new tricks, right? And I'm the old dog in this case. So none of this feels really natural. I'm so much more used to having students come into my office for office hours. But yes, for this semester, I should look into some of these other options. Hey, by the way, for office hours, I need to tell you, if you want to meet me for office hours, it's going to have to be through Zoom, and you need an invitation like I sent you guys for this meeting. And I've included those invitations on the syllabus. Go to the math department webpage and it'll be there. So I will, right now I have to set it up repeatedly each week. But I'm going to try to figure out a way so that there will be one steady number that you can just type in. Yes, Elena, you're asking about the grades for the previous homework. So the homework situation kind of got slowed down. The grader was finishing, or maybe already had finished homework 5, and then was going to, is that the one that was going to be returned on the last day of class, and then class got canceled. So we have those papers, and I think the grader is volunteering to scan them so that you guys can get them back. And meanwhile, homework 6, I have the papers, and or is that 6? 6 is the one that you guys were turning in like on the last 2 days of our meetings. So those have kind of gotten frozen between me and the grader, and we have to deal with those. So I'm sorry, there's things kind of got turned around during during the pandemic. So I apologize for that. All the papers are still somewhere. I don't think any of them have gotten lost, but we haven't gotten them all graded and certainly haven't gotten them all returned. We're going to do our best. Some of you sent us the last homework electronically. That's fine too. And in the future, that's the way it's going to have to work. A lot of you seem to write things out by hand and then scan it, and that's fine. There's some apps, I guess, for your phone that just let you kind of wave your phone over the document, and the phone's CPU just pieces it all together somehow into a JPEG or something. So all I can say is, for future homeworks, just try it, write it out by hand if that's the most natural thing for you, and find a way to scan it. If you get stuck at that point, let me know and we'll try to figure out a solution. What else do we need to say in terms of either technological things or changes in the syllabus and the grading and all that kind of stuff? Anything else that people need to ask me? Okay, well, I've been
Can you clarify on the take-home exams? Like,
what are we going to do?
Yeah, what do you like what's the intention with them?
So I guess I would like to, I will post some questions, like somewhere I can put a PDF on Canvas or the Math Department web pages or something like that. So you can see the questions and then just answer them, write out your answers, just exactly like you would if you had the printed questions in front of you during an exam. I would give you like 24 hours to work on it because, well, now we know some of you are on different time zones. And then that is, again, something you'd have to scan and send back to me. If that is a problem for you, you have to let me know, because there's some workarounds that I know, but they're not tremendously easy. But then in addition, because you guys are only 20-some students, that's a small enough group that we could still do something like an oral exam. And we don't usually do that as part of a course, but this would be my one token effort to prevent cheating, would be to actually ask you to just talk to me about what you wrote so that I know that it's actually your work. And it's not like I don't trust you guys, but I do want you to feel comfortable that everyone else is being held accountable so that you don't have to worry about somebody messing up the grade curve. And the more I thought about it, the more I just thought I actually kind of like that idea, because when it's a one-on-one situation, it becomes kind of like an office hour where I can really pin down exactly what it is that people do and don't understand and clarify things. And so it becomes a real learning opportunity. So I thought I would try that anyway for test 2, for the second midterm. If people like that and it seems to go well, we can do it again for the final. Otherwise, the final would just be a take-home exam. I would just provide the questions and you'd have a day or two to work on them and then send them back. Is that clear? Do you want me to say something else?
Yeah, that's helpful. Thank you.
Okay. We'll have to, I mean, it's still some weeks away before the second midterm was going to be anyway. So, ordinarily the university is quite clear to the faculty that we're not supposed to change the syllabus after the first day of the semester. You guys are supposed to know what you're getting into at the first day of the semester, and then I'm not allowed to change it. Well, this semester they said, all bets are off. The university is actually trying to be very supportive of both students and faculty. They're trying to give you guys as many allowances and as much leeway as they can so that you can make the most of the semester. And they're basically telling the faculty, look, that they know that we faculty members have no experience in doing this kind of stuff. And a lot of us are not real comfortable with it. And the word that we're getting from the administration is just do your best. Just treat it as a big experiment and keep changing things as you go to accommodate the wishes and the needs of the students. So that's what I'm going to do. With your permission, we're just going to experiment and do our best. So we'll have a little bit less time for material the rest of the semester, but I think we can kind of pick up where we should be by right after the spring break. And if you guys are okay with it, I guess I'd like to start working on chapter 6, and we'll be discussing some congruences. Actually, there is a little advantage to us doing these things remotely because I can share screens with you, and I've already prepared just a short little screen that shows some calculations that are, I think, more impressive to just see them happening on a computer instead of me writing them out. Oh, Jacob, you have your hand up.
Yeah, someone had asked, is there a new date for exam 2?
No, I'm not really sure I know what the old date was. Wasn't it like April, early April or something? So it was a couple of weeks away? The answer is no, I don't have a new date. Let me see real fast. I have my syllabus in front of me. Previously, exam 2 was scheduled for April 10th was the date. I guess that's only about 2 weeks from now. You want to, shall we just tentatively say April 17th? Because everything else has been pushed back a week. So let me double check to see how that would fit with the material that we're going to be able to do. But I think April 17th might be a reasonable time to shoot for. So that'll be a Friday, about 3 weeks from now. Yeah? Like everything else, it'll be up in the air for a little bit, and then we'll try. Jacob, did I get your question?
Yeah.
Okay, there. I have to remember to lower your hand when it's on my screen. All right. All right, let me turn my document camera around here. That's pretty good. All right, so let's talk some number theory. And I want to talk about these congruences, of course. We're going to be working mod n for a while. But I'd like to show you some theorems. We've already had a couple of theorems about, not so much about how do you do problems, but what do you know is true when you're working mod n for various numbers n. A lot of the stuff that we've been doing has to do with composite n. I mean, in particular, the Chinese remainder theorem helps us a lot if you have an n which is a product of two numbers that are co-prime to each other, n1 and an n2 that are co-prime. Oops, sorry. Then in this case, saying that a number x is congruent to, well, the two numbers are congruent to each other modulo n, that's true if and only if x is congruent to y modulo both n1 and n2. And the upshot is that a lot of practical considerations for these computations are handled by taking the modulus capital N and breaking it into its powers of primes. You take the factorization of the integer n into a product of prime powers, and then you work one modulo one prime power at a time. And all of the conclusions that you get modulo those prime powers, you just piece them back together using the Chinese remainder theorem to get a conclusion modulo capital N. I'll tell you where I'm going with that right this minute, is that all of that assumes that you can take your integer n and factor it. And we know in principle that that can be done. You know that every integer has a unique factorization into prime powers, but practically speaking, it can be very difficult. I don't know if any of you have tried the things that we said earlier in the semester, like taking your social security number and factoring it. And your social security number is only a modestly big integer. The bigger the integer, the harder it does get to factor. And that difficulty of factoring numbers, it stands at the heart of some of the encryption systems that people use, for example, on a computer. And I'd like to discuss that with you guys. So I want to work a little bit with theorems that we know to be true, both in the case where your modulus is a prime or a power of a prime, and in the composite case too. I'd like to see a little bit how those situations are the same and how they're different. And if we can get that far, I can show you exactly what you need to do to break internet security and gain untold riches. But it's going to be by using a lot of this congruential arithmetic. So to start, I want to handle a couple of the theorems that are in the beginning of chapter 6, one of which we've already done. So here's the theorem that's due to Fermat. One of the many theorems due to Fermat. This one says if P is prime and n is any integer, then n to the P is congruent to n modulo P. So the first thing to observe about this, so we did prove this theorem, right? I proved this by induction on n, if memory serves me correctly. So the first thing to observe about this is the following corollary. If n is an integer and n to the P is not congruent to n modulo P, then P is not prime. It's hardly a corollary, it's actually just the contrapositive of this theorem. I mean, mathematicians are fond of doing this kind of thing. You have a theorem that says, if something, then something else, but that's equivalent to saying that if this statement is not true, then that means that this condition is not true. I heard a mathematician once, he was fond of taking, there's an aphorism in English that says, you can lead a horse to water, but you can't make it drink. And he was fond of saying it as, if you can lead it to water and make it drink, then it is not a horse. So that's the contrapositive in action. But anyway, this corollary is actually quite useful. Let me share my screen. Let's see, let's do this, and now this. Share. Okay, do you guys see in front of you a computer display in black, mostly black?
Yes.
Okay, that's good. All right, so what I'm about to do with you, so I'm running Maple here, which is a computer algebra system, one of many that's available. And I'm using this to test to see whether or not the number 91 is prime. So according to the corollary that I just gave you, if the number 91 were prime, then when you take 2 to the 90th, oh, sorry, I did that a little bit wrong. If you take 2 to the 91st power, there you go, it's obviously the double. So this number that I just got, it is the double of the one that appears on your screen previously. If you reduce this modulo 91, so the little percent sign means go to the previous result, and take this thing and reduce it modulo 91. So this 37 that results, that's the division algorithm in action. I asked the division algorithm to take this as my quotient and write it as a multiple of 91 plus a remainder that was between 0 and 90 inclusive. And as you know, there is exactly one remainder that works, and that's, in this case, 37. but it's not 2. So the fact that 2 to the 91st power did not come out to be a 2 means that the number 91 is not prime. So this is what we would call a primality test. And if the test claims that the number is not prime, then that test is absolutely correct. So there are no false, is that a false positive or a false negative? I'm not sure how to call it. Anyway, but this does show that the number 91 is not prime. Now, in fact, in case you didn't know, 7 times 13 is 91. That's why 91 is not prime. But the test that I just used, it's using the converse of the Fermat theorem to prove that the number 91 is composite without ever discovering any factors of the number 91. Now, I did some other things earlier on my screen so you could see this at work. First of all, the first thing that I computed up here was 2 to the 90th power, not 91st power. That's because I used a small variant of the Fermat theorem. And let me go back to my document camera. This corollary to the Fermat theorem that I just used, it's the converse of the Fermat theorem, or the contrapositive of the Fermat theorem. It talks about raising n to the pth power on that side and n to the first power on that side. To say that n to the p is not the same as n to the first, I could restate this congruence, or this non-congruence, by dividing both sides by n. Of course, you know that when you divide by n in congruential arithmetic, you have to be careful to only divide by things that are co-prime to the modulus. So let me state this just a little bit differently. If you take an integer, well, first I'll restate Fermat's theorem. If n is an integer and p is prime, and you put on one more condition that says p does not divide n, then the conclusion is that n to the p minus 1 power will be congruent to 1 modulo p. So that just comes from taking the conclusion of the Fermat theorem and dividing both sides by n. You're allowed to do that if p is not a divisor of n, because then p and n are co-prime. So, of course, the corollary to this corollary then is that if you know that a number is co-prime to p, and I'm saying it this way instead of that way because pretty soon we're going to be talking about what happens when our modulus is composite as well. But I shouldn't be talking about not dividing n. I just want to have no common factor with n so that I can do this kind of a division. So if you have such a pair of integers, p and n, that are co-prime, and you know that n to the p minus 1 power is not congruent to 1 modulo p, then you know that p is not prime. And this is the calculation that I did a minute ago with the number, I had 91 in this position and a 2 in this position. So I raised 2 to the 90th power and I looked to see whether I got a 1, something congruent to 1 mod p. I didn't, and that told me that the p in question, the 91, was not prime. So let me go back to my shared screen. Oh, before I do, Alexander, you want to make a question or comment? Oops, sorry.
Yeah, sorry, I just had a really quick question.
Yeah,
So with
go
these
ahead.
corollaries, does this statement say this is true, the then applies for any n and z, or for there exists an n and z?
No, so this is what you see on your screen now. This is for any integer n. If you find a single integer n that satisfies these two conditions, then you know something about the p. Your conclusion is about p alone, but yes, there's a mention of an n that goes in there. So I'm going to show you an example, in fact, in just a minute, of what happens when we choose some different n's. There's some insight to be gained from different n's. That's a good question, so thank you for asking. And now, let me show you, go back to that computer screen. There we go. Is it back, the computer screen? All right, so So what I had on the screen when you guys first joined, oh no, you don't, wait, is it showing you the black, mostly black screen again?
Yeah.
Yeah, we can see the map.
Oh, that's okay, because I have a sidebar, but it's still showing me my document camera. All right, anyway, here, so I saved one step. I went one fewer power of 2 to compute 2 to the 90th power instead of 2 to the 91st power. However, I have to point out that this would be a tremendous amount of work to decide that the number 91 is not prime by taking the number 2 and multiplying it by itself 90 times to get this far. I mean, yes, you've saved yourself a little bit of trouble by not going all the way to the 91st power, but there are 2 ways to simplify this calculation. The first is to realize that, hey, you don't need to compute the giant number 2 to the 90th power and then reduce mod p. You can do all of your calculations mod p in the first place, or mod 91 in the first place. So let me show you this sequence. I'm going to take the sequence of numbers 2 to the i-th power and just replace each one of them by the residue that you get by reducing modulo 91. And I'll start with the 0th power, and I'll go, oops, sorry, I'll go up to the 91st power. How's that? All right, so here's 2 to the 0 power is 1, 2 to the 1st power, 2 to the 2nd, 2 to the 3rd, 4th, 5th, 6th. Yeah, 6, that's as far as we get. So now 2 to the 7th power, I mean, what does that mean? It's 2 times 2 to the 6th power. So I just have to multiply this number by 2. That would be 128. I could now reduce that modulo 91, and 128 is congruent to 37 modulo 91. To get to the next power of 2, I'm supposed to take the 128 and double that, and then reduce mod 91. But since I already know that the 128 is congruent to 37, if 128 is congruent to 37, then 2 times 128 will be congruent to 2 times 37. So the result of the calculating 2 to the 8th power is now just 74. So I never had to write down the number 256. I just do all of my calculations modulo 91. The biggest number that you would ever see in this whole display would be a 90. And then I could double that, and I would never have to have a number bigger than 180 on my paper. And that would be easy then to take a number as big as 180 and reduce it modulo 91. So it's actually quite simple to generate all of these numbers. You never do any calculations with numbers of more than 2 or 3 digits. Furthermore, what you see at the top of your screen makes this even easier. If you make the decision that you want to raise 2 to the 90th power, the first step should be to write the number 90 in binary. So that means that you're writing this in space 2. The number 90 is, it's no 1s, a single 2, no 4s, a single 8, a single 16, no 32s, and a single 64. So the number 90 can be written out as a sum of a few powers of 2. Let me just double check I did that right. So if I take, what was it, 2 to the 1st, plus 2 to the 3rd, 2 to the 4th, and 2 to the 6th. Are those the ones that I need? Oh, no, that's not right. What did I do wrong? Oh, I mistyped there. Yeah, I get the 90 because the ones are in positions 1, 3, 4, and 6 when you read starting in position 0, 1, reading from right to left here, starting with the 0th position. So the number 90 is a sum of a few powers of 2, and that means that if I want to raise a number to the 90th power, I could take that number, well, like this. If I want to take all of this stuff, then raising 3 to the 90th power, since we haven't tried 3 yet, that should be the same as taking 3 to, well, the sum of these powers, because you already know that the sum of all this stuff in the parentheses, oops, that should add up exactly to 90. So obviously the 2 powers of 3 should be the same. There they are, it's the same number twice. But the reason that I wrote it this way is that this one, you can expand by the laws of exponents. This is the same as 3 to the, well, 2 to the first, times 3 to the 2 to the third, and so on down the chain. Well, you know that this is going to work, so I won't do it. Here, I'm going to get an error message. Yeah, I know. Go away. Okay. Anyway, the point is that when you want to raise a number n, so this is the n in the previous theorem, 3 is now the n. To raise it to something like the 90th power really requires just a few, in this case it was a total of 4 multiplications. I'm sorry, no, 1, 2, 3, it'll just be 3 multiplications of numbers like this. But each one of these numbers can be obtained by just a few squarings. This right here, this says 3 squared. So you multiply 3 times 3. And to get 3 to the 8th power, well, that means 3 squared, squared, squared. In other words, this last line can now be written as 3 squared times 3 squared, squared, oh, I need another set of parentheses, squared, and then times the next one, which is, well, I don't feel like doing this anymore. Oops, wrong way. And then what was the last one? 2 more squarings. So I take all of this stuff and I square it 2 more times. Oops. With any luck, there you go. So I got this gigantic number by doing comparatively few multiplications. Here I had to take a number, I had to take the number 3 and square it, so there's a single multiplication. Then here I was directed to square that again. That was another multiplication. I'm up to 3. Here was a 4th multiplication. Here I just squared the previous line, so that's a 5th multiplication. And then a 6th, a 7th, and then there's a few more multiplications in here, an 8th, a 9th, and a 10th. So it took a grand total of 10 multiplications to get this gigantic number. And of course, if my goal is to just reduce all of this stuff modulo 91, sorry, modulo 91, then I could have accomplished that by doing all the intermediate calculations also modulo 91, just as I was doing up in here. So this is actually a very fast way of trying to use Fermat's theorem to decide whether a number is prime. If you take your number p, you think it might be a prime, subtract 1 to write it, and take that number and write it in binary. So by the way, this number p here, the number of digits that you see me writing down in this moment is about, well, it is the log base 2 of p. So this is a very small number of digits involved compared to the actual number that I just wrote down. And then I successively square some starting number like 2. I just keep squaring it and squaring it and squaring as I go, reducing all of those numbers modulo p. Right there's the p. And then I have to multiply together a select few of those. I had to multiply together the entries that were in the well, in this display, it's the 2nd, 4th, 5th, and 7th terms in this display, because those were where the ones were in this little expansion into binary. And I can do all the calculations mod 91 as I go. So it's a very easy thing to calculate, even by hand, to raise a number, a small number like 2, to a very large exponent like 91 or 90 and do the calculations modulo 91. Since I got, at the end of the story, I got a number that was not congruent to 1, that simply told me that the number 91 is not prime. Now, somebody was asking earlier, why is it always a 2? It doesn't have to be a 2. This 2 right there, that's the base of my expansions. That's the same as the 2 that I put in this spot, but I could have put any other number, like in this case, I put a 3. Interestingly, when I did take 3 to the 91st power, to the 90th power, I did get a 1. If the number 91 were prime, then for sure I would have gotten a 1. So the fact that I got a 1 in this case didn't really clue me in as to what was happening. It didn't tell me whether the number 91 was prime or not. Let me give you the phrasing of the theorem again. Let's stop the screen share. The phrasing of the theorem says, if you get something other than a 1, then for sure you know your number is not prime. This theorem right here says nothing in the case when you get a congruence that does give you a 1. It doesn't tell you that the number is prime. A classic example of this is, and this is actually the smallest number that works this way, if you take 2 to the 340th power and reduce that modulo 341, then you do get a 1 in this case, but the number 341 is not prime. It's 11 times 31. So the number 341 is pretending to be prime when you use 2 as the base. It's called a mod 2 pseudo-prime. The fact that the number 341 is not prime is revealed as soon as you choose another base. Oops. Because in this case, I did not get a 1. So that tells me it's the use of 3 is the thing that clues me in, that tells me that 341 is not prime. There are some numbers that are composite, but they're particularly dastardly in the sense that you can take...
There's some questions on the chat.
Oh, thank you. Oh, it's 2:50. You are right. Thank you. We are ending. I'm going to quit. All right. Thanks for letting me know, guys, because I can't follow this. I will let you play. Those of you who have a calculator like this, try the number 561 and see what these corollaries to the Fermat theorem tell you. All right. Can we convene again on Wednesday at the same time? I will be here. I will hold it to an hour. I do appreciate you guys stopping me because I know I have a tendency to go long. Oops, that shouldn't have happened. If you guys have any suggestions for how to make this run better, please just send me an email. I will be recording this. I will send you the location of the recorded video on YouTube, and we'll see how that kind of mechanism works. All right, and I'll see if that April 10th, whatever it was, whatever day I just said, we'll see if that works for, it was the 17th, to see if that works for an exam too. All righty, guys, thank you for coming.